My class. In this video, I'm going to explain design of DFA. In the last video, I explained about what is DFA and how we can represent DFA. I explained the transition diagram and transition table. Those two are used for representing DFA. Okay, so in this video, I start explaining construction of DFA. Here I took one example. Okay, na? So based on that example, we can easily construct transition diagram and transition table. The transition diagram is called DFA. Okay, na? Now I'm going to explain one by one example. First, I took example is like type 0 problems. So all the type 0 problems are like all the strings of language, okay, na? Ending with some substring. So problems are like constructing DFA. Here we are going to construct a DFA. So generally DFA is used for accepting languages. Okay, na? So here we are going to construct a DFA that accepts languages. So what do you mean by language? Consisting of group of strings. Okay, na, or words. So all the languages consisting of strings ending with a particular substring. So for this we are going to construct a DFA. So ending with one substring is there at the end of all the strings. So same substring is there at the end of all the strings. So such type of languages we are taking, and based on that we are constructing DFA. So it is very easy if you can remember 4 steps. Okay, it is very easy constructing transition diagram or DFA. Okay, now so first step is, so first we need to determine how many number of minimum states that are required, minimum number of states required. Then how can we calculate minimum number of steps now? So anyway, ending with in the question itself containing ending with so and so substring. Okay, na? So starting any number of, suppose if you say that ending with ABB is Z now. So ABB means, so starting with any number of A's and any number of B's, but finally that string should end with ABB. Or starting with any number of zeros and any number of ones, suppose ending with 001. Let us assume that is the problem. So either 001 or ABB is treated as Z. Then how can we decide the number of states which are required? So first calculate how much size is there in Z. What is the size of the Z? Size of the Z means the number of character positions are there in Z. Suppose in ABB, the number of character positions are 3. In 001, number of character positions are 3. So based on mod Z. So mod Z is number of positions in the string, means length of the Z. Suppose if length of Z is n, then DFA is requiring n plus 1 states. Please remember this. Okay, na? In ending with problems, if ending with any substring, if substring size length is n units, then we require n plus 1 states for constructing DFA. So once after deciding n plus 1 states, immediately draw the states. So we can start with Q naught. Suppose n is 3. Suppose 001. Then 3 means 4 states are required. So those 4 states are Q naught, Q1, Q2, Q3. So Q naught is the initial state. Q3 is the acceptance state. Okay, na? So first draw those states. Now after deciding the number of states required, then we need to draw those states without any connections. Okay, na? Now decide the strings for which DFA will be constructed. Now we need to decide on which strings we are going to construct DFA. I will tell you after taking one example. I will tell you how to construct the required strings. Okay. In first step, we calculate minimum number of states which are required for constructing DFA, and we draw on those minimum number of states. And in second step, we decide the strings for which we are going to design DFA. Very easy. Deciding strings is very easy. I will tell you with one example. Okay, na? So after deciding strings, we need to construct a DFA for the decided strings in step 2. So in the step 2, we need to construct strings for constructing DFA. In third step, we need to construct a DFA for the above decided strings. Here we need to decide the strings for which we are going to construct DFA in step 3. Okay, na? So always prefer existing paths, maximum prefer existing paths. Whenever existing path is not possible, then only calculate or construct a new path. Okay, na? This is third step. So start constructing DFA for the above decided strings. While constructing DFA, maximum utilize all the existing paths only. So whenever existing path possibility is not there for showing the string, then only create a new path, that is step 3. Now after constructing DFA with all the decided strings, Because in DFA, we must show each and every transition on each and every symbol from each and every state. From each and every state, we have to show each and every transition on symbols. Suppose two symbols are there from each and every state, we need to show two symbols related transitions. So sometimes, because here we decided strings, okay, those decided strings may not fulfill this condition. In that case, after drawing the DFA by using step 3, okay, na, on decided strings in step 2, sort the or whatever the leftist transitions. I told you now, suppose if A transition is there from Q naught, there is no B transition from Q naught. Suppose there is a B transition from Q1, there is no A transition. So such type of left transitions are blindly connected to starting state. Whatever the starting state you are designating in diagram, blindly connect all the remaining connections which are left after constructing DFA by decided strings. Simply connect those connections to the starting state. So if you remember these 4 steps, we can easily construct DFA. I will show you one simple example. Okay, now suppose question is like, draw the DFA for the language accepting strings ending with ABB. So start with any number of A's and B's. This is the regular expression for this question. Starts with any number of A's and B's, even epsilon. ARB whole star means epsilon. This means only ABB. Or 1A followed by ABB. Or 1B followed by ABB. Or group of strings with size 2. Group of strings with length 3. Group of strings with length 4. But finally, all these strings must be ending with ABB. So this is this regular expression syntax. Okay, na? Then what is Z here? Z is ABB. What is the size of Z? 3. Size of Z is 3. Actually, if size of Z is n, then how many states are required? 4 states are required. N means n plus 1. 3 means 3 plus 1 states are required. That is first step. So in first step, we need to find how many number of minimum states that are required to construct transition diagram or DFA. Now, after deciding, we need to draw those states. Four states are required now because mod ABB equal to 3. Then 4 states are Q0, Q1, Q2, Q3. Designate Q0 as initial state. Initial state can be represented by using arrow. Any state is represented with arrow is called initial state. And acceptance state is represented by using double circle. If any state is enclosed within double circle, then that is acceptance state. And all the remaining circled states are intermediate states. Okay, so this is first step. We found number of states required to draw the DFA, and we constructed those states. Next one is, what is the next step? Deciding strings. So what are the strings based on which we are going to construct DFA? Very simple. Deciding strings is very simple. First take ABB. This is first string we are going to show on this diagram. Next, take first letter from ABB and write ABB as end. ABB, don't forget writing ABB. Though you are taking letters combination from ABB, okay, na? Write ABB as end. So take first character and write ABB. Next, take first 2 characters and write ABB. Next, take first 3 characters and write ABB. So no other character is left. So these are the strings required. Suppose ABBB. Then first take ABBB. Anyway, we write. Next, take ABBB, you write. Next, take ABBB, you write. Next, take ABBB followed by ABBB. So once you get left side part also same as right side part, means ending with string, then we stop constructing strings here. So for these 4 strings, we are going to construct DFA first. How can we consider strings now? First take the conditioned string. Now take first character or first position character and write ABB. Next, take first 2 characters and write ABB, because don't forget, because all the strings must end with ABB only. Next, take first 3 characters and write ABB, and so on. Okay, na? Only 4 strings are available here because only three characters are there. Then first we write original string. Then after we write original string, before original string first character, before original string first 2 characters, before original string first 3 characters, and so on. So the number, this is, in this way we can construct any problem. ABBA, ABBBB, whatever the number of symbols here, we need to construct those number of substrings, including this extra. 3 characters are there, 3 plus 1. If 4 characters are there, 4 substrings we need to construct. One is with first character, second one is first 2, third one is first 3 characters. Don't forget writing ABB. This ABB must be there because all these strings must end with ABB. So in this fashion, we can construct substrings. Now, after constructing substring, we are going to construct a DFA. Very simple. First, show this ABB on this diagram. A in between Q0, Q1. Yeah, A between Q0, Q1. B between Q1, Q2. B between Q1, Q2, 3. So ABB is satisfied. By using ABB, we reached Q3. Okay, na Q0 on A, Q1, Q1 on B, Q2, Q2 on B, Q3. So finally, after reading ABB, we reached Q3. So first string is over. Now show second string. What is the condition for drawing? Utilize all the existing paths maximum. So next string is ABB. Anyway, ABB available. In previous diagram, ABB is available. But extra character is ABB. Then take self loop here. ABB. But finally, if you read the string is ending with ABB. Even you take any number of times this A, finally A followed by BB. Then this is also valid. What is the next string? AB, ABB, AB, ABB. Use existing paths only. Maximum use existing paths. AB, ABB. So up to this we can use AB. But extra A is there. Then we can use BB. But how can we use this BB? Then come back to this state on A. Okay, na? AB. Of course, ABB is there. But our string is AB, ABB. AB, ABB. Anyway, BB you can utilize. But if you come back one step, then we can utilize BB. So that particular step is form on A. So AB, ABB. Then third string is also. Next one is ABB, ABB. ABB. Straight away we can use ABB. Next again we can use BB. Then for using this BB, you are supposed to come back from Q3 to Q1 on A. Q3 to Q1 on A. So in this way, we can construct a DFA on decided strings. So first string is ABB. So first construct a diagram with ABB. On ABB, this particular machine should accept ABB. Accepting ABB means after reading ABB, machine should end at acceptance state. So there are 4 states, Q0, Q1. In between Q0, Q1, use A as symbol. Q1, Q2, use B. Q2, Q3, use B. So ABB, by reading ABB, we can reach Q3. Next one is AABB. But condition is maximum you utilize all the existing paths only. Existing path is ABB. But in between, one A is extra now. Then if you take self loop here on A, then we utilize BB. Okay, na? A, BB. You can use any number of times this particular A. But finally, last A followed by 2 Bs. ABB is there na? Next AB, ABB. In this path, ABB is there. AB is also there. AB is also there. AB, ABB we need to read. But one more B is there here. But if you come back to this state, we can utilize these 2 Bs. So that's why we came back to this particular Q1 on A. So AB, ABB. Okay, na? Next one is ABB, ABB. So anyway, ABB is available now. With ABB, we can reach acceptance state. And one more ABB is there. But here we have BB. We cannot reach here because only 3 symbols are there. If you reach that state with 1 symbol, but there is no such symbol here because only A is there. But after A, we can utilize these 2 Bs. That's why we need to come back to Q1 from Q3. So ABB, after ABB, one more ABB we need to show, but BB is available straight away. But for utilizing this existing path, just create one new path from Q3 to Q1 on A. So ABB, ABB. Okay, na? Now this is the DFA construction based on decided strings. So this is DFA based on decided strings. Okay, na? Decided strings. Now, what is the last step now? This is not full DFA. Full DFA means we need to show the transitions from each and every state on each and every symbol. There are 2 symbols. So Q0 on B is missing. Q3 on B is missing. Anyway, Q1 on A, B is there. Q2 on A, B is there. Q3 on A is there. B is missing. And Q0 on B is also missing. Then what 4th step is saying? For all the left transitions, whatever the left transitions that are there, simply or blindly connect all the left transitions to initial state. I already initialized the state here. Na? I forgot writing a state arrow here. Anyway, arrow should be followed. Okay, na? To initial state. So B, you need to give all the left transitions to initial state only. So B is missing, then Q0 on B is Q0. B is missing from Q3, then Q3 on B is Q0. So this is the final a DFA. Okay, na? So for the left transitions, all the left transitions are connected to initial state. Even left transition is there at initial state, we need to connect left transition to that state itself, because B is not showing in earlier diagram. Then Q naught on B is Q naught only, because Q naught is initial state. B is missing, then connect to initial state only, and Q3 and B is missing, they connect Q3 and B to Q naught blindly. Wherever the transition is missing, here also, even Q2 and B is missing, then simply connect Q2 and B to Q naught. Wherever transitions are missing, blindly connect the transition to initial state only. So in this fashion, we can construct a DFA for the languages containing strings ending with any substring. Very simple. Okay, na? Then after constructing transition diagram, simply write 5 tuples: Q, sigma, delta, Q. This is delta. Delta means transition table. Q naught F. So Q is Q naught, Q1, Q2, Q3. What is sigma? Input symbol CAB. What is Q naught? Q naught is initial state Q naught. F is set of final states or acceptance states Q3. Okay, na? What is transition table? Transition table is showing all the transitions. So delta of Q naught comma A equal to Q1, delta of Q naught comma B equal to Q1. Delta here we are using transition function as delta. Delta of Q naught comma A equal to Q1, delta of Q naught comma B equal to Q naught. Here from this diagram only I am filling this table. So here also initial state is represented by using arrow, and acceptance state is represented by using either star or circled state. I explained in DFA basic information, like representation of in DFA transition table is there. There I represented acceptance state with either circle or star. Just by using these representations, we can easily identify which is initial state and which is acceptance state. We can also enclose Q3 in circle or put star before Q3. This is initial state. So by seeing this diagram, we can fill this table. After this, we can also cross-check any string which is ending with ABB is acceptable through this diagram or not. Suppose if you take AAABB. So what is Q naught on A? Q1. One A is over. Another A is there. Q1 on A is Q1. B. Q1 on B is Q2. Q2 on B is Q3. Finally, machine stops at Q3. So like this, we can cross-check any string. Suppose if any string is not ending with ABB, suppose ABA is there or BBA is there, which may end at any intermediate state or acceptance state. Other than acceptance state, the machine may stop at either Q0, Q1 or Q2. If the string is not containing end characters as ABB, if end characters are ABB, then machine stops at Q3. If end characters are not ABB, then machine may stop at Q1, Q2, Q3. Like suppose ABBA, if we take ABBA, Q0 on A, we can reach Q1. Q1 on B, we reach Q2. Q2 on B, we reach Q3. Again, A is there. A, B, B, A, na. Q3 on A, we reach Q1. Of course, string is over. Then machines finally stopped at Q1. So like this, we can cross-check by using this transition table or transition diagram with the delta transitions. We can verify whether the given string is acceptable through this designed finite automata or not. So this finite automata can be constructed with one particular condition, that is ending with. Okay, na? This is one particular type of problem. Okay, in the next video, I will explain starting with. Suppose if you want to construct DFA containing or accepting the language containing strings starting with so and so substring, then there is a simple procedure like this procedure. There is a simple procedure. By using that procedure, we can easily construct a transition table on this transition diagram. From that, we can construct transition table and we represent 5 tuples, and we can also cross-check any string, whether that string is acceptable or not. Okay, na? So thank you for watching my video.